Okay, finally, the history lesson that I've been talking about. Here is the unit circle. This is my preferred unit circle because this unit circle has, and I'm going to count for you, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spokes on the wheel, but this one doubles up for numbers, so 17 degree measurements. For my radians, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 radian measurements. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 coordinates. So we double up on radians at the 0 degree, 360 degree, 0 radian, 2 pi radian mark, but everything else just has one set of coordinates. Now, if you go to Google Images, you may not find a unit circle that has all this information on it. I highly recommend that you handwrite on, if you've got a resource sheet coming to you in any course, I recommend that you handwrite on 17 degree measurements, 17 radian measurements, and 16 coordinates. Just because then it's as complete as possible and you won't overlook anything. So what I'm going to do, and it might take a lot of scribbling and it's going to be ugly, what I'm going to do is I'm going to go through and put all this information on in a way that hopefully helps you draw this for the future. So, step 1. Here's my X and Y axis. And what I'm going to do, now that I have a center, is I'm going to dig out my circle maker and make myself a circle. Now, I've gone out in each direction a little bit extra, which is nice. And this is a unit circle. So before I start to do anything crazy, I am going to put on the fact that this is a unit circle. So let's do this in black. This dot is 1 out in the X and 0 on the Y. This dot is -1 on the X, 0 on the Y. This dot is 0 on the X, 1 on the Y, and this dot is 0 on the X, -1 on the Y. That guarantees I've got a unit circle, meaning I'm going out 1 in every direction. It also means that all my other radii from center to outside, dogfight, from center to outside, all of those are going to be ugly-ish. But they're all still going to be, sorry, can you hear that? They're all going to be 1 unit from the edge. So if you think about the unit circle, we're going to need to at least eye up a 45 degree marking in this direction and extend it back through quadrant 3. I will need a 45 degree marking in this direction, and I will need to back it up into quadrant 4. And this is where you are super estimating. I need a 30 degree marking in this direction, and I need to back it up. I need a 60 degree marking in this direction, and I need to back it up. I need a 30 degree marking in this direction, and I need to back it up. And finally, I need a 60-degree marking in this direction, and I need to back it up. So hopefully you can see already why a printout is a little bit better than a handwritten one, because I'm already making a mess. Let me move these into more useful positions. Okay, so red for degrees. There, that's what I was looking for. So this is 0 degrees. This is 30 degrees. This is 45 degrees. This is 60 degrees. Hopefully this is no surprise at 90 degrees. Then this is 30 degrees more than 90, so this is 120 degrees. This is 45 degrees more than 90, so that's 135 degrees. And this is 60 degrees more than 90, so that's 150 degrees. And hopefully it's not a surprise that this one's 180 degrees. Keep going with this. This is 30 degrees more than 180, which is 210. This is 45 degrees more than 180, so 225. And this is 60 degrees more than 180, so this is 240 degrees. And 190, 290, 390s is 270 degrees. This is 30 degrees more than 270, so that's 300. 45 degrees more than 270 is 315. 60 degrees more than 270 is 330. And then we have 360. And there are your 17-degree measurements. Next thing, I don't know how that turned color. I want to put on my radians. So you can take every single one of these and you can turn your degrees into radians using your conversion factor. I'm going to show you a different way of taking care of it. It also means that I have a bit of scribbling. So I'm going to use blue this time just to be consistent with the other unit circle. Blue, perfect. And there is going to be some scribbling, but I'll plunk them all here. So this is 0 radians, and that's the only one I'm going to put rad on. The other ones will have pi's, so it's going to be kind of implied. So 30 degrees times pi over 160 is 1 pi over 6. We need to worry about that. So this is pi over 6, and I'm going to skip all the 45s for the time being. This one is 30 degrees more, so it's 2 pi over 6. And 2 pi over 6 reduces to pi over 3. And this one is another one, so it's 3 pi over 6, which reduces to 1 pi over 2. Then the next one is 4 pi over 6, which is 2 pi over 3. That's a 45, so I'm skipping it. 5 pi over 6, doesn't reduce. 6 pi over 6 is pi, which should not be a surprise. 7 pi over 6 doesn't reduce. Skip the 45. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 will be the next one. I just keep going up by 1 on the top. Is 3 pi over 2. 9, 10 pi over 6 is 5 pi over 3. 11 pi over 6 will not reduce. And now I can go back to my 45s. So 45 times pi over 180 is 1 pi over 4 reduced. This is 2 pi over 4, but I've already got a label. This will be 3 pi over 4. 4 pi over 4, got a label. 5 pi over 4. 6 pi over 4, but I've got a label. So this is 7 pi over 4. And can you see where I've missed one? Right here, number 17. 8 pi over 4, or 2 pi, but you should have known that for 360. So now, there is a memory aid that is just a little bit mathy, but not why. There's a memory aid for how to put on the coordinates. So what goes here for the x comma y, sine comma cos, or cos comma sine for each of these. So I'm going to take you downstairs and go through it. So this is how the heck are you going to remember all this information? But really there's a whole bunch of patterns. So first thing, 0, 1, 2, 3, 4. For each of them, take the square root if you can. So yep, 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 nope, so repeat, nope, so repeat. Then divide all of them by 2 and clean it up where you can. So yep, yep, nope, nope, nope. But I guess the point is you should recognize these numbers as unit circle numbers if you've done the unit circle work. So back to this. Let me take a sec to erase my scribbles. And some of you are going to look at this and say, how about I just memorize it? It's way easier than that. And that is totally up to you. So here's what I want you to notice. It's 0, then a half, then root 2 over 2, then root 3 over 2, then 1. Remember this list. I have it memorized temporarily. If I look at the first coordinates starting at the top of the unit circle, it'll be 0, then 1/2, then root 2 over 2, then root 3 over 2, then 1. On my way up, 0, 1/2, root 2 over 2, root 3 over 2, and 1. Now, when you go over to quadrant number 2, it's going to be exactly the same. So I'm going to see, actually there's no way that they're glued together, so I'm going to have to write them down. So this one is 1/2 comma root 3 over 2. It's just reflected. And this one is root 2 over 2 comma root 2 over 2. And this one is root 3 over 2 comma 1 over 2. But to get over in this quadrant, we have to go left then up. So all our first coordinates have to be negative. Then when I go down here, I can take each of these and I can reflect them. So this one reflects here, but it's negative negative because it's left and down. And the middle one reflects into the middle, left and down. See, I told you this is going to be messy. And the top one left and down. So we've got one last quadrant left. It's quadrant 4. I usually go back to quadrant 1 here and restart. So these are going to reflect. But this is right, so positive, and down. Middle one, right and down. And right and down. And you have your entire unit circle. Now, if you're sitting there thinking, oh my gosh, that's a ton of work, it's actually less work now that you've got it, so you can do the questions. So the work is pre-work before you start anything, and then you have it for whatever you need it for in a test, exam, whatever the case is outside of this class. Now remember, if you're with me, tell us you have a resource sheet. So you'd have to make one of these once or print one of these and check that you have 17 degree labels, 17 radian labels, 16 of these coordinates. So the next thing I want to lead you through is the unit circle, because depending on where you went to school, probably not TAS, you might have, did I say unit circle? Special triangles. You may not have used the unit circle. In fact, when I went to Crestwood way back in the olden days, we didn't know the unit circle. I learned it when I got to TAS, and now it's all over the internet. I'm going to show you the special triangles. So the special triangles actually create these numbers, so the unit circle was based on the special triangles. This is just a memory aid. So this may take me 2 slides because there's 2 special triangles. So I'm going to show you how to remember them, because way back in the olden days I could not remember the special triangles even though I was supposed to. So it was very temporary in my brain. So the first thing you can draw for your memory aid on this is an equilateral triangle. And I hope everybody realizes that when you have an equilateral triangle, all the sides are the same length and all the corners are the same size, and that is 60 degrees. So we have to decide the best number to put on the sides of this, and the best number is honestly a 2. I will explain why in a second. Seconds up. What you're going to do with this triangle is you're going to cut it in half. That's why a 2 is good, because you can actually cut it in half. And when you cut it in half, what you end up creating is 2 of these guys. Now, just for space, flip. Just for space, I'm going to use that side. So both of them are the same. I'm going to use this one. And I'm going to take all the information I've put on this triangle and I'm going to move it over here. So I've created a right angle triangle. This is 2. It's not equilateral anymore. This is 1 because I split it in half. This is 60 degrees. And then we have to figure out some other things. For instance, I know that this is 30 degrees because if I took a 60-degree angle and I cut it in half, that makes that 30. So I have all the angles inside this triangle, which is special because these are the numbers that are in the first quadrant of the unit circle. And then finally, we need to figure out the length of this side, which is a non-hypotenuse. So in order for me to figure that out, it'll be hypotenuse squared equals, I'm going to call it y because it's on the up and down, squared, plus 1 squared. So that's 4 equals y squared plus 1. 4 minus 1 from the other side. And because it's a triangle, I don't have to worry about the plus minus, so I get root 3. And you should recognize these numbers from the unit circle because this is what helped create the unit circle. This thing that I just made is the 30, 60, 90 special triangle. Some of you, gosh, I'm slow with this today. Some of you are going to want to write another version of this triangle where this is still 90, this is still root 3, this is still 2, this is still 1, this isn't 60 anymore, it's pi over 3 radians, This isn't 30 anymore, it's pi over 6 radians. So you may want a radian version and a degree version, totally up to you, but that is the 30, 60, 90 special triangle. So there's another one, and that's because there's another number missing from this triangle onto this unit circle, and it's 45. So to create this one, again, I could remember this one. It was the one that we just finished that I couldn't do. And this one is a right-angled isosceles triangle. So a right-angled isosceles triangle will force you to have 90 degrees here, and that'll force 45 degrees in here and 45 degrees in here. These two sides will be the same length. And again, we got to figure out what side length to put on here that'll make this most useful, and the answer is a 1, because we don't have to split any of this stuff in half. So now I'm going to find out the hypotenuse. So hypotenuse squared equals 1 squared plus 1 squared. And again, I'm finding out the side length of a triangle so I don't have to worry about the plus minus. And that's a typo. And this is your 45, 45, 90 special triangle. And again, some of you may want to take this triangle and make yourself a new one, which instead of having 1 root 2, 1, 45 degrees, 90 degrees, you'll have pi over 4 radians, pi over 4 radians, 90 degrees, or pi over 2 radians. So these are your special triangles. So instead of the unit circle, I had to memorize those when I was in high school, and now what I want to do is I want to show you how this works to do these 3 questions, which were the exact same 3 questions that we did with the unit circle. So I'm going to show you that sine 30 is still going to end up being as a 1/2. Cotangent 585 degrees is still going to end up as a positive 1. And tan 120 will end up with negative root 3. Now, if I'm not mistaken, there will be an alternate answer for this, in which case we'll do some fancy square rooting, uncoolness, and get rid of it. So bear with me, and we'll come back and we'll do a little double check. So we need exact values, the y. So special triangles. Now remember, this is what I have to do, and if you don't like this, you don't have to like this, because you have the unit circle to back up. I had nothing to back up. So the first thing that I had to do back in high school with the special triangles is I had to doodle me a little 30-degree mark. So here's my picture, and I knew 30 degrees was in here, and I drew a triangle down to the x-axis, so 30 degrees was in the bow tie. And then what I had to do is I had to put 60 degrees here, and I had to put all the markings for the special triangle on this thing. So it was pretty intensive doodle. So if I go back to this, my 30 degrees is the littlest number. It's across from the littlest value. My 90 degrees is the biggest number. It's across from the biggest value. And my 60 is across from the middle. So I had to remember that. So 30, that makes this 1. 90, that makes this 2. That makes this root 3. We had to worry about what's positive and what's negative, so fortunately I've picked a first quadrant angle to worry about the fact that we don't have worries about positives and negatives right now. But the next thing I had to do was figure out opposite over hypotenuse. So you go to the 30-degree mark, that's where you plant, that's your opposite, that's your hypotenuse, that's your adjacent. Opposite over hypotenuse is 1 over 2, doesn't need reducing, and we're done. And it should not surprise you that that's the answer. The next one I'll go to is this one. And you may already think, okay, I'm shutting this off. This is not my preferable way, and that's just fine. You have a backup. So, doodle time. Maybe I'll make this one just a touch bigger. So 120 degrees is here. Draw to the x-axis, and you can't put 120 in here. I mean, this is your 120. So you got to figure out how much is sitting in here, and the answer is 60 degrees is sitting in there, because if that's 120 and this is 180, that's the 60 to make it up. That forces this to be 30, and there you go with your special triangle. So 1 goes here, 2 goes here, root 3 goes here. I realize I did a terrible job of drawing this, as in it's not to scale. This is a left and up triangle, so I need a negative there. Opposite, hypotenuse, adjacent, tan is opposite over adjacent, so that's root 3 over negative 1, which is negative root 3. I lied. We didn't need any conversion, but we got the same answer. And then the last one is this one, so I'm kind of hoping for an answer of 1. So the unfortunate part of the cotangent of 585 is the 585. So I still don't know what that is because it's over 360. So I still have to do this stuff. And then I can draw this picture. So 90, 180, somewhere in here, drawn to the x-axis. How far in there? 45 degrees. Should not surprise you. The answer is either going to be you're trapping a 45, a 30, or a 60. Go figure. That's why they're special triangles. And so this is a 1, this is a 1, this is a root 2. This is a negative because it's left, this is a negative because it's down, and that's always a positive because it's the hypotenuse. Opposite, hypotenuse, adjacent, cotangent is the upside down of tan, so it's A over O. So negative 1 over negative 1 is positive 1, and I'm no longer hoping. I know the answer is 1. So there you go. Just because I have a little bit of extra time here, I don't believe this is too long for a history lesson. A reminder of the cast rule as I go back through this. Just going to doodle it. So this is cos is positive in here. All are positive in here. Sine is positive in here. And tangent is positive in here. That means the other ones are negative. So basically, this is a statement about the positivity of your trig ratios. So that's why there's a big plus sign in here to remind you. So if I go through my pictures on this page, this is a quadrant 1 angle, and we ended up with a positive. That should not surprise you because they're all positive. While I've got it sitting here, this is a quadrant 1, 2, 3 angle, so I'm expecting tan to be positive or cotangent to be positive. And cotangent really is positive. So my answer ends up as a positive ratio. And then the last one that I have up here is this one, so it's quadrant 1, 2, and in quadrant 2, sine is positive, cosecant is also positive. We did a tangent question, so it should not be a surprise that you have a negative ratio. So that's the use of the the cast rule, C-A-S-T. All students take calculus, all students take careers, all students take civics. We will go into much more detail with the cast rule in the next unit of trig, so after we're done all the identities and stuff. So that is it for the history lesson. I am done, and we're going on to more identities next. Have a good one.